In this video, we're going to estimate the line of best fit for a set of data. So first we're going to make a scatter plot of the following data, and we're going to draw a line that appears to be the best fit for the data. And we'll discuss how to determine that. And then after that, we're going to find the equation for this line of best fit. So the data we have is the hours the students studied versus their grade received for a test. So when we have 0 hours, it said we got a 30%. When we had 0.5 hours of studying, we got a 45. When we had 1 hour of studying, we had a 50. When we had a 1.5 hours of studying, we got a 52. When we had 2 hours of studying, we got a 68. When we had 2.5 hours of studying, we got an 86. When we had 3 hours of studying, we had an 80. When we had 3.5 hours of studying, we had an 89. We had 4 hours of studying, we had a 90. When we had 4.5 hours of studying, we had a 98. When we had 5 hours of studying, we got 100. So, this is our data we're looking at. Now, we have some steps for finding the best fit. So, first we're going to use a straight edge, like a ruler, and we want to kind of put it on this data, and we want to find a line so that it cuts the data points roughly in half. The best thing to have would be that the line we find intersects the majority of the points. But in our case here, that's really not going to happen. So looking at this, you want to have about an even number of points above the line as you have below the line. So if I decide to draw my line right here, I have 1, 2, 3, 4 points below it. I have 1, 2, 3, and kind of 4 points above it. So it's about roughly even. And then we also have our initial point of the 30 down here. So I guess there's 5 points below and 3 or 4 on top. This is kind of a general rough estimate because what we're doing is just visually trying to determine what this line might be. This is not like a mathematical way to do this. And because of that, often you'll get different results from different people because it is an opinion thing. So to determine the equation of this line, we can look at 2 points it might go through or some other method. So if we look at this, we can see that our line intersects the y-axis at about roughly 43. So we can use that data to help find our equation. Now let's see what else we can maybe use. So looking through our data, we also see that we have the line crossing a point up here, and that point is at the 4 hours studied. So this point here is representative of our 4, 90. And our line pretty much goes right through this point, or just is right by it. So we can use that other point to help us. So we can say it also intersects 4, 90. So the next thing we do is we're going to use point slope form. We can do that. And what we're going to do is we know that this 43 is actually a 43 for our y component and a 0 for our x component. So this isn't the data that we initially had. This is the data for our line. That's an important distinction to make. So from these 2 points, first we're going to determine our slope. So slope is going to be y2 minus y1 divided by x2 minus x1. So let's do this as a 90 minus 43 divided by a 4 minus 0. And when we do 90 minus 43, we're going to get 47 divided by 4 here. So instead of actually carrying that out, because we know we're going to get a decimal, let's just leave that as a fraction. Now we know what point, we can just use the 4, 90 or the 0, 43. And we're going to substitute that. So let's use our 0, 43 just to make it a little simpler. So we know y minus 43 must equal the slope, which was 47 divided by 4 times x minus 0. This is simply point slope form. So remember that's y minus y1 equals m times x minus x1. So whenever we carry this out, we're simply going to get that y equals 47 divided by 4 x plus 43. So that's going to be our equation for our line. So based on this, we've created a useful equation that tells us essentially this is the grade you might expect for this test given the number of hours you study. So that's estimating lines of best fit.